started in a minute. Before we do, we've been reminding everybody at every session, so forgive me if this is repetitive, but we're having a networking reception at 6:30 p.m. in the 4th floor library area where you've probably been at one point today. You ride the elevator up to the top, and we're going to have, I think, some drinks and a DJ, and there's this beautiful patio with a fantastic view of Playa Vista all the way to Century City and beyond. So you should definitely check it out for at least a little while. So our next speaker, I'm sure you're all very excited to see. It's Chris Stevens. He's a senior data engineer for Netflix. He gave this talk at a LA Big Data Users Group meeting a couple of months ago, but it's been updated and expanded, and it's about rapid analytics at Netflix. Chris.
Thank you very much. So it's great to see everybody here today. As our introducer said, my name is Chris Stevens. I'm a data engineer with the Content Analytics Group here at Netflix in Los Angeles. To kind of answer first question, we get this a lot from people that we talk to in the Silicon Valley. They say, you guys are in Los Angeles? And the answer is yes. We've got a pretty big presence in Los Angeles. Our office has, I think, more than 600 people at this point. We're building a new 14-story building in Hollywood. I've heard that it is the largest office space lease in Hollywood's history. So we're definitely kind of positioning ourselves for the Los Angeles office to grow. We're going to be moving there in early 2017. And so Netflix's content analytics team is growing. We don't see that. So we're hiring Python software engineers, data engineers, data analysts, data visualization folks, and data scientists. And we want to continue to talk with the growing tech space here in Los Angeles about how we can make Los Angeles a great place, a great technical employment location in the U.S. What we're hoping to talk to you guys about today was moving quickly in a large-scale data environment. Netflix has kind of a nuanced view of what it means to move quickly. If anyone's read our culture deck, we talk about our goal as being big, fast, and flexible all at the same time. So since we started in the late 90s, Netflix streaming has grown to serve more than 80 million customers. We've got $6.5 billion in revenue last year. And so we've grown to become very large in size. But our goal is to always strive to operate like a much, much smaller company. So to operate without the kinds of controls and processes that can make companies rigid and that can make companies lose their flexibility and lose their ability to adapt to changes in the market. So one of the primary ways that we think we can accomplish that is by creating a culture of freedom and responsibility within the company. So this goes for all employees, but for engineers specifically, I wanted to talk to you guys a little bit about what that looks like. So we'll go through a couple of examples, a couple of areas where our team thinks that freedom and responsibility has differentiated the way that Netflix works in the big data space, as opposed to other companies that like our group collectively have worked for in the past. So we'll tell you a little bit about what we think has worked well. So one of the first things is that every engineer on the Netflix content analytics team can drop tables in production whenever they want. So what we mean by this is that Netflix has taken a look at what the cost would be of mistakes being made in a production environment. We try to remember that our data warehouse, while it is a very important part of Netflix's operations from an analytical perspective, it's not a true operational system, right? So if we lose a table in the data warehouse, Netflix's business doesn't stop. Netflix doesn't stop streaming to customers. It's an inconvenience for people that are trying to do their analytics. But generally speaking, everyone in the company, if the data warehouse is down for a little bit, can still functionally do their job. They can still move forward. So rather than kind of only having a limited number of people have access to make changes in production, we take the path of hiring people that we exercise good judgment. And what we found is that most people don't accidentally log into production and write drop table, giant fat, right? People don't typically slip up like that. And those types of mistakes are infrequent enough that the tax of having a rigorous deployment process for data products into production is not worth kind of the value that that protection would provide. So I don't want to make it sound like we're constantly kind of on the edge at Netflix. We have definitely architected some protection into our system. But what I want to kind of make clear is that architecture was very intentional. We built the system with the idea of having production access for everyone in mind. So an example of one of the things that we do to protect ourselves, in our Hive data warehouse, all of our tables are external tables that point to S3 locations. So every ETL job that runs, the output format components will, instead of writing data directly to the location that the table metadata points to, it'll write the location with an epoch of the time that new data was written. This gives us the advantage of swapping the metadata kind of at the last minute. Our components that are writing tables effectively do like an alter table set location kind of command in Hive, and they update the metadata to point to the new location. So this means that while this batch is filling up, the table still points to the old location. So you only have an instant where the metadata is being swapped. And we also have the advantage that if we do a drop table command, our tables are external tables in Hive. So we don't actually lose any data with drop table commands. We do have processes that go through and clean up these old batch IDs. So if you saw Paul's presentation in the morning, we've got 40 petabytes of data on S3. And so we can't let this stuff stay out there forever. But we do have a little bit of protection if there's an oops. It lets us go back and easily roll back to the previous day's data. And usually that's good enough to get us moving for a little while. In our MPP databases that are set up a little bit differently from Hive, our admins have put together a stored proc just called upgrade privileges. And anybody at Netflix can log into the database, upgrade their privileges, and do production deployments. So of course, any call to this procedure is logged. We know who's doing it. And it's set up so that it only lasts for a few hours. So that normally, when we're querying in our database environments, we don't have root access. So people kind of know that when they turn this on, they're being intentional about, and it's kind of a mental note that you have to be a little bit more careful when you're working in production with these privileges turned on. So the bottom line for us is that operating in this fashion has removed a significant step in the delivery of data products. When other teams are getting to the point where they're ready to move their new data products via new reports or new data models into production, we're already done at that. We're ready to move on to the next one. So the second thing that we think is a little bit different in the way that we operate from other companies that our team has collectively worked for in the past is that our engineers are free to adopt the technology that is right for the problem they're trying to solve. So Some folks don't know this, but Netflix does not have a CTO. And they don't have somebody with a different title that acts like a CTO. When I say we don't have a CTO, I really mean we don't have a CTO. And we don't have architects, we don't have technical fellows. The way that Netflix sees our staff is that we pay top of market, we recruit great engineers. That's who we try to hire. So if we've hired great engineers, it makes sense to us to allow those engineers to make technical decisions and to choose the technologies that make sense, because they're the ones that are closest to the problem. And we find that if you tell people ahead of time that the company is kind of trusting their judgment, people do really well in that environment, and they make good decisions, and they balance cost versus the benefits that they'll get from using a particular technology. So as an example, our product analytics was recently doing a refactor. They found that they had a process in place that was loading tens of billions of records a day using kind of a mini batch style. So they were working on a visualization tool for our A/B testing that was a very interactive web app. So somebody who was evaluating the performance of an A/B test, and by an A/B test I mean if we've released a new feature for the Netflix product and we kind of show that feature to a small subset of accounts, and we want to see what the behavior is of those accounts relative to the behavior of other people, right? So we run thousands and thousands of A/B tests trying to improve our product. So this is an interactive app that will allow you to see how A/B tests are performing. So the app is very interactive. We needed sub-second response time when users are clicking from place to place. And so we wanted to see if there was a way that we could get this tons of data ingested into aggregations, very specific aggregations, that were available at levels we had in mind ahead of time. So we knew that there was a better solution than mini batch. So what we do in Netflix when we have opportunities like this is our data engineers have the freedom just to try stuff out ourselves. So in this case, our data engineers used a tool we have internally called Spinnaker. It's our cloud server management software. We use this to spin up a Druid cluster and a Spark cluster, and we just started a POC. So at the end of the day, actually I should mention this too. We let our data platform team know that we were doing this, but we weren't doing that to kind of get their approval or even to get their buy-in. It's known at Netflix that the engineers that are implementing the solution definitely have the authority to choose the technology that they want to choose. But we let our data platform team know what we were doing because we value their opinions and their experience. And what they said when we told them we were doing this was, great. I think those are great technologies. They look like they're a great fit for the problem. Let us know how your POC turns out, and let us know if there's anything we can do to help you with it. So as it turns out, Druid worked great for our use case. So we proceeded by taking the cluster that we had set up in test and just promoted it to production. And we supported the Druid cluster as part of this A/B test visualization application. We were running a forked copy of Druid so that as we came up with things that we needed to change about the open source software, we could submit patches back to the main project. And if there were any patches that weren't accepted for some reason, we could run a slightly different copy that would better meet our needs. And by the way, it was our data engineers that were making these changes to Druid code base. They have the freedom to do that. After the solution was in production for a little while, our data platform team took a look at it and said, hey, this is a great use of a new technology. And they took over support for the Druid cluster because they thought it would be beneficial to more teams than just the product analytics team. So the question we get a lot of times when we talk about our approach to problems like this is, man, every engineer in your environment can spin up a cluster whenever they want to. How do you control costs? How do you keep a lid on things? And the answer again comes from this Netflix's culture deck. It's a very different way of doing things, but for us, it's been working really well. Netflix's management style is context, not control. So instead of trying to limit who can start up clusters, we try to make sure that all of the engineers that are going to take an action like spinning up a cluster have the appropriate context. So our Spinnaker tool shows how much a cluster is going to cost on a monthly basis when you go into the tool to try to spin a cluster up. We also have company-wide reporting that pretty much anyone can go out and take a look at that shows how much money is being spent on cloud resources by group, by application, by manager, by individual owner, along a lot of different fronts. So we found that by just kind of providing that context, and our platform teams don't have to spend a whole lot of time trying to limit what people are doing up front. They can just kind of take a look at the larger picture and then reach out to individual teams and guide them if they see any outliers in the reporting. The analogy we also sometimes use on the context not control is, okay, so how many people have done this? You're going out to dinner with a friend, and you know that they're paying, so you order steak and lobster. But if you aren't sure if they're paying, then you kind of like look at the menu a little bit more closely. If you've done that, you're a terrible friend, and I'm never going out to dinner. You should just admit it now. No. Yeah, so this is kind of the point, right? Netflix's philosophy is that great employees travel like they would travel personally. They eat out for business like they would eat out personally, right? You keep the way that you operate in your personal life kind of the way that you would operate for business, and we try to be careful with the company's money, just like we're careful with our own money. And this applies to whether we're traveling for business or whether you're spinning up clusters to use for a project. So spinning up clusters is kind of a big example, but I think that this philosophy applies to very small things in our environment. So recently, our content analytics team was taking a look at a process where we had a pretty small table that we had to write an ETL process to sync between an interactive web application that was updating some data in this table and an ETL process that was loading the same table from a bunch of different places in our data warehouse. And we kind of every day had to sync the data back and forth and manage which changes were winning. And it seemed like kind of a big process for a pretty small table. So as we thought about it, we thought, why don't we just try backing the table with DynamoDB? At the time, we don't have HBase in our environment, and that seemed like kind of an overkill solution. We were looking for something that was small and quick. So what I thought was really telling about Netflix's environment was that it was really simple and low cost in terms of time for us to try something like this out. We just went out to one of our servers. The AWS CLI let us create the DynamoDB table. we put a Hive table on top of it, and boom, now we have a small table that could be updated through a REST API, and that could also be read inside of our data warehouse using the same underlying data. For our small use case, we haven't pushed this to production yet, but it looks like it's going to work beautifully. So the third thing that we think is a little bit different in how we operate than other places is that we try not to restrict our content data engineers and data business intelligence engineers into specific roles. So maybe you guys have run into this. Let's say that you've got a BI engineer that's building a report and they need their data structured in a certain way. Now what's happened at a lot of companies that I've worked for in the past is that the BI engineer has to go find a data engineer and ask them to create an additional table, to restructure the core data model into a way that will kind of work better for their reporting needs. In our environment, the BI engineer often will just go out to our production job scheduling tool. They'll write a Hive script that builds a table on top of our core data model, and they'll land it in a reporting schema, and then they'll write their report to hit that table directly. And they'll own and manage this very small job that kind of restructures data for a specific report. We try to focus on centers of excellence and say that our data engineers have a lot of expertise in data engineering, but they're not limited to only doing data engineering. And similar rules for business intelligence engineers, for software engineers, for all kinds of engineers in our environment. So I think a pretty cool example of this. So our BI engineers, where's Jason? Is Jason in the room now? Jason, if you're in here, wave your hands. No? Okay, he's at the booth. So we had a few BI engineers on my team that were getting pretty frustrated with their lack of fine-grained control over how reports coming out of Tableau and MicroStrategy would look. So one day, they just decided to sit down to try and write a Python script where you would provide a file of SQL, you would provide a Jinja template, and it would kind of pull data from the database and construct an HTML email using Jinja and would send it out to users. And it worked great. Using this solution, they could get really fun. I mean, they had access to the HTML and CSS at that point. So as you can imagine, they had really fine-grained control over how the emails look, to the point that they knew what email clients everybody in the company was using, and they could kind of optimize the HTML and CSS for those specific email clients. And we made the email reports that we were working with just much easier to read at a glance with really a pretty simple solution. So this was something that our BI engineers did on their own, and ended up kind of open sourcing internally so that other data groups within the company started using the same solution and have found it to be really beneficial. So, we have a ton of other examples of this. All of our data engineers have Tableau licenses, so if the reports that are necessary coming from a particular data model are really simple and straightforward, it may not make sense for us to accept the overhead of introducing a new person to the project and kind of getting them up to speed with context. If it's really simple reports, the data engineers may build the tables in the data warehouse and then just put the simple reports right on top of them themselves. Right? So we always make that decision about whether it's worth the context switching to get more people involved. Okay, so I just got the signal that I'm at about 20 minutes. I want to leave some time for questions. I've got a bunch more examples in backup, but these are just some of the ways that we've tried to remain fast and flexible and do rapid analytics as we've grown and gotten bigger. So does anybody have any questions? Right here. So what are some examples of using Python to automate our tasks? So our data platform team actually put together a set of Python APIs. They call it Craggle from the Lego movie, the Crazy Glue. Remember that? That's what they call our API set. So they've created a Python API that exposes access to all of our databases, to our Druid clusters, to our job scheduling tool. So we will use Python to do backfills for very large tables. We'll write a script that will iterate through time, and then we'll fire off jobs that can stay on the cluster so that we don't have to stay on a machine to use them. We also use Python scripts to create TDEs. So our BI engineers can create Tableau data extracts using scripting, and this can be very helpful for cases where you're maybe creating a large TDE and you just don't want to work with the tool interactively. You want it to happen in the background on a schedule basis. Other questions? Yes, back there.
Is Spinnaker open source?
Yes, Spinnaker is open source. Yes. Yes.
How do you manage all the engineering and you things and start to put it into that how do you do that and manage for duplication?
Yes. So the question is, if all of our engineers are doing kind of whatever they want, how do we prevent people from doing the same work and kind of duplicating efforts? So a two-part answer. Part of the answer is that we accept that one of the consequences of moving quickly is that you're going to get some duplication, and that we definitely have instances where two different teams maybe solve the same problem in two different ways, and don't use the same solution. Or maybe two different teams that solve very similar problems using two completely different technology stacks, and we look at it afterwards and we say, man, if we would have done this together, it would have worked really well. But there's a couple of caveats to that. So our managers know that we are running independently, so they do a very good job of syncing with each other at a high level and providing context to other teams on what their teams are working. So we'll get updates all the time that'll say, oh, the product analytics team is doing this new implementation with Druid, and here's kind of the problem, and here's the approach that they're using to solve it, so that if we have some insight, we can go talk to them about it, or if we're dealing with a similar problem, we can kind of hear what it was that they were doing. We also have realized over time that teams tend to build solutions that are really oriented for their customers. And it seems at a high level that sharing implementation is going to make things faster because you have to do less work. But you oftentimes spend as much time coordinating between teams that are using a shared solution than you'd spend just kind of doing it two different ways independently, but being able to move quickly and directly service your customers' needs. So we really look closely at the value of using an integrated single solution and make sure that it's worth the cost of communicating and kind of staying. Other questions? Yes.
Notice you mentioned a lot of open source tools. My question is, when you're hiring, do you have a tendency to favor people who have this DIY type of initiatives?
I don't. I find myself not really thinking about that very much while when interviewing candidates. I'd say the biggest reason that Netflix uses open source technology is that we've got great engineers on staff, and we've just found over time that it's better for us to have access to the source code and to be able to make changes when we need to kind of progress our business instead of waiting for a vendor to let those changes kind of bubble up in their backlog. So certainly people with background in the technologies that we use can hit the ground running in our environment, but it's less about whether someone has been involved in open source and more about whether someone has experience with the tools and the problems that our group is trying to solve. Yep.
Does your company have a separate team specially handling data science or machine learning that goes into content implementation?
Yes. So does our team have a separate team that focuses on machine learning and data science? So yes, we do. Netflix has separated our data science organization from our data engineering and analytics organization. So at our keynote, you heard our VP of Data Engineering all talk. And earlier today, Todd Holloway was up here. Todd runs the content science and algorithms at Netflix. So the way that we try to separate things is our data engineering group tries to make sure that our data scientists don't have to spend 90% of their time massaging data, restructuring, aggregating data, which is a story that we hear a lot from data scientists in the industry. We try to make sure that our data engineering team builds a clean data warehouse and data model and can do the data preparation that's necessary for the data science team to really focus on research and to be able to move as quickly as possible.
So in what kind of scenario where try you have a collaboration between the teams and what kind of project?
Yeah, sure. Actually, I might have to think about that for a minute. Like the last time that we collaborated with one of the other teams supporting a different business unit. One of the biggest, there's a bunch of things that we have to watch out for when we've got a number of independent teams solving problems in their own ways. So one of the things that our management is kind of hyper aware of is the duplication or the redefinition of certain metrics. So the way that we tend to split things out is our content data engineering group kind of owns a portion of the enterprise data model. And everyone knows that there are certain metrics that are kind of the content team's metrics. And the content team is in charge of the definition of those metrics. So any team throughout the company can use the tables that we've built. There's kind of an understanding that they need to keep our definition of that metric, so that things don't get really confusing at a high level. So we get questions from other data teams all the time about so for example, one of the dimensions that the content team maintains is our database of movies and TV shows. And we get questions from the product team and from the marketing team all the time about specific attributes in those tables. And we just kind of, they know that we're the subject matter experts in those areas. Anybody else have other questions? Okay, well thank you guys very much for coming. And, if you want to talk any more about this stuff, look me up on LinkedIn.